Hey guys, so this video is going to focus on how to simplify complex fractions, specifically when you're dealing with maybe some rational expressions here. Now, when it comes to complex fractions like the one I have over here, essentially complex fractions are fractions within fractions. Right? So here we notice that we have a few fractions going on here. But honestly, when it comes to dealing with complex fractions, it helps to sit back and remember that this fraction bar, right? I have this fraction over this fraction over here. So I have this big old fraction over here. But it helps to remember that that fraction bar means to divide. Yes, it's a fraction, but it also means division. So, in my opinion, it's always easier to keep that in mind because if it's just division, well, why not just rewrite it as a division problem instead? So, my first step in order to simplify this down is to rewrite the problem. So, instead of making it kind of one big ugly fraction like this, rewrite it side by side as division. And what I mean by that is do this. So we're going to take 4z cubed x to the 6th over 9, and let's divide it by 12x squared z to the 7th over 21. So rewrite it side by side like this, and rewriting it side by side like this, I don't know about you, but it always helps me see what I need to do in the problem next. Because if I'm dividing here, so I just see dividing two fractions. Well, we need to remember the rule for dividing fractions. So how do we divide fractions? And the rule for dividing fractions says this. It says we keep the first one. So we're going to keep 4z cubed x to the 6th over 9. We change the division symbol to multiplication. And we flip the second one. So we take the reciprocal of the second fraction. So keep, change, flip. So that's the rule for dividing fractions. Now, the division rule for dividing fractions, all it does is changes it into a multiplication problem to where now I'm going to be multiplying this together. And when we multiply fractions, that's top times top, bottom times bottom. But when it comes to multiplying rational expressions, what we want to do is we want to actually not multiply the whole thing together because in rational expressions, we're actually working on breaking them down and simplifying them. So we don't want to multiply them and make them even bigger. What we're going to do is the multiplying step is just a combining step. We're going to combine it all into one big problem. We're going to take, so 4z cubed times x to the 6th times 21 over 9 times 12x squared z to the 7th. Just write it all as one problem like this. So don't actually multiply 4 times 21 and so on like that. Just kind of group it all together in one. Now, this is actually the multiplying step here. So we rewrote it side by side. We used our division rule. Now all we have to do is simplify this thing. And when it comes to rational expressions, simplifying actually means we'll factor it. So taking a look at this problem, all we have to do is see what can be factored, what can be broken down, and then we're done with the problem. So then we need to think, well, how do I factor this here? So first thing when it comes to factoring is, well, how many terms do I have? Because a lot of times counting the terms that we have gives us a big clue into what factoring technique we're going to use. Now, we only have one term here. One term in our numerator, one term in our denominator. And when all we have is one term, there is no special factoring technique for that. We can't do grouping or reverse FOIL or difference of squares or any of those factoring techniques with that. When we have one term, all we can really do is expand our problem. Actually write out the multiplication. What's going on here? And what I mean by that is do this. Starting with the numerator. 4 is a 2 times a 2. Z cubed, well that means I have 3 z's. X to the 6, I have 6 x's. So 1, 2, 3, 4, 5, 6. And then 21 is actually a 3 times a 7. So that's what I mean by expand the multiplication. Stretch it out. Do the same thing for the denominator. So in the denominator, the first thing I have is a 9. So that's 3 times 3. Then I have a 12. So a 12 is 2 times 6. But the 6 is 2 times 3. So I really have 2 times 2 times 3 there. Okay. Then I have x squared. So I have 2 x's. And then z to the 7th. So 1, 2, 3, 4, 5, 6, 7. All right, so that's everything. When you're done factoring your numerator and denominator, next is my favorite step. You get to cancel. Remember in math, we have this rule that says anytime you have the same thing over itself, those cancel and you're left with a 1. So what we're going to do is anything we have in the numerator that we also have in the denominator, we're going to cancel it out. So let's see. This 2 is going to cancel out. Another 2 is going to cancel out. 3 of those z's will cancel out. 2 of the x's will cancel out. Let's see. A 3 will cancel. And I think that's it. Okay. So do go over everything just to make sure you did cancel everything that you do have. Otherwise, your answer is what you get when you put that all together. So taking a look at the numerator, let's see. I have 1, 2, 3, 4 x's. So that's x to the 4th. And then I also have this 7 over here. So I actually have 7x to the 4th. And then in the denominator, I have 3 times 3, which is 9. And then let's see, I have 4 z's, 1, 2, 3, 4. So in the denominator, I have 9z to the 4th. So this right here is my simplified answer. So if you just rewrite it side by side and use the division rule, I think it makes this problem a lot more doable.